So my name is Konstantin, and I'll learn how to use this remote. Just another second. So there are just 3 buttons. I'll use my finger, and I just press spacebar here. So I work for Facebook on Marketplace team, and I mostly focus on performance recently. Before joining Marketplace in Seattle, I worked in Facebook UK, and I worked on Yarn Package Manager. Anyone loves packages? And before that, I worked on React Native, so I'm a little bit biased towards what framework to choose when you build a mobile app. So today I'm going to talk what I have been working on for the last year, actually making Marketplace load faster. Just before we start, anyone is familiar with React? Nice. How about React Native? Much less. So this talk is, I made it so that you could actually take it home, some ideas how to make your application faster, specifically React Native. But it also applies to React, and actually, if you think about it, it applies to any other application. So first of all, what is Marketplace? Anyone used Marketplace before? So it's a platform. It's actually a tab inside Facebook application. Anyone knows about Facebook? So it's a social network. And there are tabs in it, and Marketplace is one of the tabs. It's a place where you can buy and sell things to people in your community. So Marketplace started in 2016, and it took us to build the first version for iOS just 6 months. And actually, we tested it in Hawaii. So it means that this talk sort of brings it back home. Then it took us just 2 months to build the Android version. And this is actually quite rare for applications of this size in a company of this size, because it's usually like 6 months iOS, then another 6 months Android. But because we reused JavaScript and 90% of the code was reused, we were able to do it just in 2 months. So it officially launched in October 2016 to mainland US and some other countries. And now it's global, and there are more than 800 million people using this application every month. And Marketplace is more than just buying and selling items to people around you. It's also about buying a car, finding a place to live, some daily deals, some business opportunities, quite a lot. The team is quite large. It's more than 100 engineers working on the same React Native code base. So Marketplace grew from 0 to 800 million in just about 2 years. And the team grew as well. So we need to hire more people, and we need to make the application nice to work with. And React Native played a big role in how to make a good developer experience. So anyone is familiar with hot reloading? Anyone knows the difference between live reloading and hot reloading? All right, not everyone. So live reloading is when you develop a website, you change your code, type something, save it, and then your browser or application refreshes with the latest code, and you see the changes. Hot reloading is when you make your changes on your laptop, like here. I make some code changes to my React component. I press save, and then it goes to the device, and only the components that actually changed get re-rendered. As usual, React re-renders components at its pleasure. And this iteration is quite fast, because I'm just changing code a little bit, and here we go. And another thing that you probably don't know, at Facebook, we don't like building the Facebook application. We love the application, but building it is not fun, because it takes 30 minutes to have a new binary on your device, because we have millions of files. Something good about React Native, as I mentioned, 90% of the code, or even more, is written in JavaScript. And we don't need to change the native code that often. So what we can do is we can grab the latest binary from a build server, install it on the device, and then build the JavaScript file from the source code. As a matter of fact, we have integration with our IDE that just grabs this binary and does everything with just one single click. Another big deal is hiring people. As I told you, Marketplace team has grown a lot to build a lot of features. And at Facebook, we have a joke that it's really hard to find Android developers because we already hired every Android developer who wanted to work for us. So we need coincidentally, there are more JavaScript developers around. Still hard to hire them, but possible. Less than 5% of people working on Marketplace are actually specializing in native platforms. It doesn't mean that we don't use their skills. We just leverage their ability to work on something complex, platform-specific. All the other people are quite quick to adapt to the JavaScript code base and become quite proficient building features. React and React Native are also very popular. If you count GitHub stars, which I do periodically, they are probably in top 10 frameworks on GitHub by star count. Of course, it doesn't matter. But if you look at the number of contributors, individual people who contribute to the code base, React Native is one of the top projects. And also, it built a community around it. What I'm saying is that when we hire people from outside to work on Marketplace, those people are very likely already familiar with our technology. And it means that they can be productive straight away. So I just described React Native, a JavaScript framework that allowed us to grow the team fast. But what about JavaScript and building an application that works fast? JavaScript has a lot of things that people say that it's not good for performance. It's garbage collected. Anyone else has ideas? Yes? Dynamic typing? I'm just kidding. I actually have it written here. It has module system that's not really mature enough. We have different module system. It's single-threaded. How do you build a UI when single-threaded? But thankfully, we actually have asynchronous code and coroutines. But anyway, a lot of people are biased about JavaScript, and there are reasons. So Facebook occasionally surveys people who are using their applications. And there is a direct correlation between how fast the application loads and how satisfied are people with the application. And performance work that we did on Marketplace in the last year shows that people engage more with the application if it loads faster. For every 100 milliseconds, there is a certain % of improvement of how people engage with Marketplace. And I'm not talking about just looking at the screen and then going away. I'm actually meaning that it sticks to people if something loads fast. So Facebook application leadership spent some time researching how fast the application should be for people to feel comfortable with it. And in the last 40 years, there have been a lot of researches. And the consensus is that if a computer system refreshes a screen within 1 second, then people perceive that it's fast. So that was the goal for all the tabs at Facebook. How do we make them fast? As in, load within 1 second, and on a slow device, like this Samsung J5 Prime, which is not the nicest device around, but surprisingly, it's one of the most popular devices in the world. So we started with 3.5 seconds for 75% of people loading Marketplace. And when we heard about the goal, we thought, well, it's a bit humorous, 70% improvement. Are you serious? A year passed, and turns out they believed in us, and they were serious, so we are getting closer. So what I'm going to talk next about is how we achieved that. And I tried to focus on things that you people working on React and React Native could actually bring it home and reuse it. And even though many people hold JavaScript as a liability of React Native, I think it's on the contrary. We have many years of experience optimizing websites. And if you haven't seen this talk from Ilya Grigorik from 6 years ago, pretty much everything applies to optimizing React Native. So similar to optimizing websites or any other application, we start with measuring all different subspans, how things are loading. Then we find the slow things, and we make a decision. Is it something that we really need at the startup that we call the critical path? Or is it something, and if it's not, let's just do it later. And if it is, let's do it in parallel with something else. So what's another cool thing about JavaScript and ability to debug your applications is that JavaScript can run on many things. And there is a feature called debug JavaScript remotely on React Native. And not a lot of people realize that it's actually sending the JavaScript application of React Native to the browser. It executes the full application, builds the component tree, and then sends signal to the device telling what needs to be rendered in the native code. So full JavaScript is for real running in the browser. And it means that we have access to the development tools that are coming with the browsers. For example, in Chrome, I can click Performance tab. I can click Record and get some samples. And then it has a very good integration with React. And React Native is running React.js inside it, so we actually have a very nice flame chart of all the components that are loading. And we can see which components are slow or which components are unnecessary. And we can make some assumptions like, let's not have this component, or let's optimize that first. Now, you have to take this with a grain of salt, because we are running this on a desktop browser, on your powerful MacBook, probably. And it's a V8 JavaScript engine. On a real device, it will be a JavaScript core that runs on Android and iOS. And it's a completely different picture. But if you really want to have the same flame chart, there is a tool called systrace that just collects the traces, and it integrates with React Native. And you can see how your components work on a real device. So measuring performance is actually an art. We could be have a separate talk about how to measure performance on a group of people, on a large group of people. How about the distributions between different people? What kind of category of devices exist? But I think the first two tools that I showed you could be a good start how to start improving your performance. So now let's actually look at what things helped us to improve React Native. So this one is an obvious one. I'm pretty sure everyone who is running a mobile application should be running the network request in parallel when things are loading, because you're doing stuff on the server and stuff on the client. They shouldn't be interconnected. However, there is a caveat. I know some people are using GraphQL here. Who likes GraphQL? Yeah. So with mobile and GraphQL and JavaScript, there is a caveat, because usually people using React Native, they use JavaScript implementation of GraphQL. For those who don't know what GraphQL is, it's a concept that allows your components to define what they need. And it means that the query for the data is based on the components. So you need a GraphQL engine that would inspect your components, build a query, and then send this query. And if it is in JavaScript, you see the blue line. We need to start up JavaScript VM. We need to start up React Native. We need to start the bundle. We need to find the GraphQL JavaScript implementation, and then send the request. What we should be doing is running it in parallel. So if you are using React Native or a very similar framework and the GraphQL, you should be questioning, how can I make the request in parallel? At Facebook, we have a very thin layer implemented in native code that is capable of sending the request from Java or from Objective-C. That's how we achieve that. Also, I brought you some good news. If you update to latest React Native, you will know that it has the latest JavaScript core engine. For those who don't know, JavaScript Core is the JavaScript engine that React Native is using. The problem is that it hasn't been updated for 2 years. And it has been 32 bits, and now we have the latest one that's 64 bits. It's not only good for library compatibility, but also it comes with 2 years of optimizations and performance tweaks. It's one of the easiest things that you can actually do to improve your React Native performance. Oh, this one is really cool, but legal department didn't allow me to mention anything about it. Just imagine unicorns exploding with jelly beans. Moving on. Now let's talk about what we can do to the JavaScript bundle. By default, all React Native surfaces in our application are compiled in one JavaScript file. This is a very common technique. Anyone using Webpack? Pretty much everyone. So it compiles all the JavaScript in one JavaScript file. It gets zipped and sent over the network to the device. With React Native, it's a little bit different. We want to optimize it differently. The problem is that this JavaScript on React Native is actually part of the application. And if we want to load any React Native screen, we need to read this file. And if it's large, like 6 megabytes or maybe 20 megabytes, it's quite heavy for I/O. It will take time to load. So ideally, we want to split it into two, like Webpack can do. You can have a very small JavaScript bundle for your initial screen, and then you can load other things later, for example, on click, or maybe it's a different surface. Now, the trick is that actually for React Native, we don't need to do that. There is a feature called RAM bundles. It's a fancy name, means random access memory, but what it actually does, it compiles every JavaScript module into its own file and puts it in the application. So when you start up your application, you only read the modules that are required in your initial startup path. And it means that you only pay I/O only for the modules that you need. Now, talking about requires and imports. Let's imagine we have a very heavy component. Like, I even called it very expensive. And let's say it does something nasty, not just this console log that indicates that something nasty, like it mines a Bitcoin for you. Now, you want to use this component, but you know that it mines a Bitcoin, so it's very slow. So what you do, when you use it on line 20, you say, hey, don't load this very expensive component before I make a click. There's a conditional for the state. But you didn't know that import is actually eagerly loading. And it means when we have on line 3, import very expensive component, you actually get a Bitcoin mined. We don't want global code executed during our startup time. So what we can do is change the import into the old CommonJS require that allows you to import files within the functions. So we define a new variable called let, very expensive. It's undefined by default. And then on the key press, we say require this module, and then it becomes available as something to render. Now, obviously, you don't want to do it for everything in your application. So thankfully, React Native Packager that's called Metro Bundler has this setting that automatically translates all your imports into these require statements. So you can write idiomatic JavaScript, but it's smart enough to find that components are not used during the startup. It converts them into require statements, and you don't pay the extra thing. So we talked about what things you can do with your configurations, as in other people build parts of your application, build frameworks for you, and you can just tweak some knobs and get it work faster. Now let's talk about what you can do to your production code. So you can find a lot of information on the web about optimizing React components. The gist of it is we don't want to call render function multiple times for your component. And React is very generous about calling render because it's supposed to be fast. However, if it's critical for you to don't call extra extra times the component, then you can do some tricks. So here is a common way how we can avoid it. This component implemented should_component_update function. The idea is if it returns true, then the render function will be called. And if it returns false, React will trust you that this component shouldn't be re-rendered. In this case, we look at the property color, and we say, only update this component, only re-render this component when color changes. This concept is very popular, so there is a pure component in React. What it does, it automatically implements should_component_update for you, and only calls re-render when a prop changes. And I'd like to finish my talk on a point that focusing on perception can give you more results than actually grinding the components. Here is what I mean. By default, React builds a component tree, depth first. So we have some top component, and it goes down, down, down to the most inner component in it, then goes up, up, up by the stack, then goes again, and it kind of builds the whole tree. Now, React Fiber is coming to React Native soon, but for now, we don't have this way to prioritize things, how to load them. So, for example, in Marketplace, we can decide that, hey, user content is more important than a fancy navigation at the top. And we could save 50 milliseconds by just delaying the navigation, the header, and show the components, the user content that people could engage with. Here is how you can do it with React Native. So you can define that, all right, this header is very expensive. I don't want to render it from the first go. But how do I know that it got rendered at all? Because components are built in JavaScript, and code is rendered in the native. And there is some communication between those threads, but they're completely independent. You cannot just say, wait for 100 milliseconds and then render the header. Because 100 milliseconds on a slow device may pass, and you start rendering the header before anything rendered on the screen, so you slow it down. But we have a trick. For example, I created a little view component on line 23, and it has an onLayout callback. This view is actually invisible, but React Native still renders it. When we have this view rendered, we know that, hey, this component already was rendered by the native code, so we can do things that we wanted to delay. So it has the onLayout callback that goes to line 7, and that's when we change the state of the component and say, hey, render other things now. As a matter of fact, in Marketplace, this was one of the most common things that we have been doing. React Native application is just one large component that goes into more smaller components. And in Marketplace, we were saying, all right, this looks like a heavy component. Let's delay it. The problem is that we have a large team and a lot of features. So these components started piling up. And of course, we started delaying them, but there are a lot of layers, a lot of things that JavaScript has still to go through. And when we measured this just didn't sit with me right. We spent 500 milliseconds on a slow device to render this screen. Because we have flat list, we have many things, we still delay them, but we can't delay everything because the code will be really hard to read. But really, I can implement this thing from scratch, and it would run under 200 milliseconds because it's just 4 images. I can just do a view and put images in there. So we thought about it, and we implemented this. We decided to do a little trick. So we implement the light one, and then destroy it, and render the full view with all the flag stores and craft. And of course, this is not shippable. This is a terrible experience because it blinks. But not everyone knows that React Native has a very good animation library that allows you to run an animation when a component is destroyed. So for a couple of weeks, we tested a few ideas, And this is what we settled with. We render the light view with the trans within 200 milliseconds. In the background, we build the full view with all the craft that takes 500 milliseconds. Then we destroy the light one, and we animate in with the fade out into the thing that's already in the background. This way, we have quite indistinguishable change. But at the same time, the light view is already clickable, and people can engage with the application much sooner. So let me summarize what I talked about today. Marketplace is on a great trajectory and keeps growing. React Native is one of the tools to satisfy the product growth needs. And we can use our experience from the web, from optimizing all those websites for many years, and apply it to React Native, and in general, mobile JS on mobile. That's all.